The 2025 Atlantic hurricane season is approaching. It officially begins on June 1st. Residents in coastal areas should begin their preparations. The season will continue for 6 months, concluding on November 30th. We are currently in late May 2025, a crucial time for outlooks. The atmosphere is transitioning into a pattern conducive for storm development. Forecasters are already looking at the conditions. Early indications suggest what we might expect. The first named storm of the 2025 season will be Andrea. Naming storms helps in clear communication and tracking. Each year brings its own unique set of atmospheric and oceanic conditions. These conditions will dictate the character and intensity of the hurricane season. Current projections point towards an average to slightly above average season. This means we could see a typical number of named storms, or perhaps a few more than usual. An average season typically has around 14 named storms. This includes about 7 hurricanes and 3 major hurricanes. Even a season predicted to be average can be devastating. If a major hurricane makes landfall in a populated area, the impact is severe. Therefore, preparedness is key regardless of the overall seasonal forecast. We must always be ready. Tropical waves are a fundamental component of hurricane seasons. These waves originate over the African continent. They then move westward across the tropical Atlantic Ocean. Not every tropical wave develops into a more powerful storm. However, a significant majority of Atlantic hurricanes start as these waves. Their journey across the warm ocean waters is critical for potential intensification. Each year, a substantial number of these waves traverse the Atlantic. We typically observe between 60 to 70 tropical waves during a single season. These waves march across the ocean like a procession. They bring with them clusters of showers and thunderstorms. The strength and organization of these waves can vary greatly. Some are weak and disorganized, others show early signs of rotation and development. Meteorologists track these waves meticulously from their inception. The development potential of these waves is a key forecast challenge. Only a fraction of these waves intensify into named storms. On average, about 10 to 15% of tropical waves become tropical depressions. The process requires warm ocean waters, low wind shear, and sufficient atmospheric moisture. Understanding and tracking tropical waves is therefore crucial. Early warnings can provide valuable lead time for preparations. Ocean temperatures play a critical role in hurricane development and intensification. Warm water acts as the fuel for these powerful storms. Hurricanes draw their energy from the heat stored in the upper layers of the ocean. Generally, sea surface temperatures need to be at least 26.5 degrees Celsius or 80 degrees Fahrenheit. This warmth must extend down to a depth of at least 50 meters. This provides the necessary heat and moisture to sustain a tropical cyclone. As of May 2025, we are observing specific patterns in ocean temperatures. Water temperatures in the Caribbean Sea are slightly above normal. The southern Gulf of Mexico also shows similarly warmer conditions. These above-average temperatures could provide ample energy for developing storms. This is a factor that supports the prediction of an average to slightly above-average season. Warmer waters mean more potential fuel is available. This can lead to stronger storms if other conditions are also favorable for development. Therefore, monitoring sea surface temperatures and oceanic heat content throughout the season is vital. It helps us assess the likelihood of storm formation and intensification across different parts of the basin. The National Hurricane Center, or NHC, is central to hurricane forecasting and warning in the United States. Based in Miami, Florida, the NHC is a component of the National Weather Service. Its mission is to save lives and protect property. They do this by issuing watches, warnings, forecasts, and analyses of hazardous tropical weather. Their experts work around the clock during the hurricane season. They provide critical information to emergency managers, policymakers, and the public. The NHC employs a variety of sophisticated tools and techniques. They use data from weather satellites, including geostationary and polar orbiting satellites. These provide continuous imagery of the tropics. Aircraft reconnaissance is another vital tool. Hurricane hunter planes fly directly into storms. They collect invaluable data on wind speed, pressure, and storm structure. Weather buoys and ship reports also contribute to the data pool. Complex computer models are run multiple times a day. These models simulate storm tracks and intensity. The process of issuing a forecast is meticulous. NHC forecasters analyze all available data. They discuss the model outputs and consider the current atmospheric environment. They then issue official track and intensity forecasts for any active tropical cyclones. The importance of the NHC's work is immense. Their accurate and timely warnings allow communities to prepare. Section 5. A glance across the basin, the Pacific, and Storm Alvin. While our primary focus is the Atlantic, it is useful to note activity in other basins. The eastern North Pacific hurricane season also has its own patterns. It officially began on May 15th, slightly earlier than the Atlantic season. Conditions in the Pacific can sometimes offer clues about broader atmospheric patterns. However, Pacific storms rarely impact the Atlantic basin directly. Their circulations are distinct and separated by the landmass of Central America and Mexico. Currently, the Eastern Pacific could see its first named storm of their season soon. This storm, if it forms and reaches tropical storm strength, will be named Alvin. Forecasters at the National Hurricane Center also monitor this basin. They issue advisories for tropical cyclones in the Eastern Pacific. The development of Alvin would signal the start of tropical activity there. It is a reminder that hurricane season is a global phenomenon. Different regions experience these powerful storms under varying conditions. The development of storms like Alvin in the Pacific is watched, but its direct implications for the Atlantic are generally minimal. Section 6. Early season predictions. Gauging the season's strength. Predicting the overall character of a hurricane season months in advance is a challenging task. Several research institutions and government agencies issue seasonal hurricane outlooks. These predictions typically provide a range for the number of named storms. They also predict hurricanes and major hurricanes. These forecasts are based on a variety of factors. These include current and projected sea surface temperatures. They also consider the state of ENSO and climate models. For the 2025 Atlantic hurricane season, the consensus among early predictions is for average to slightly above average activity. This aligns with the information we have discussed. Factors like the slightly warmer than normal waters in key development regions support this outlook. The expected neutral ENSO conditions also play a role. Neutral ENSO years can be quite variable. They lack the strong suppressing or enhancing influence of El Niño or La Niña. It is important to understand the limitations of these early forecasts. Seasonal outlooks provide a general sense of the season's potential. They cannot predict exactly how many storms will form, nor can they predict where they will track, or if they will make landfall. Section 7. Understanding ENSO. Its influence on hurricane activity. The El Niño Southern Oscillation, or ENSO, is a significant climate pattern. It influences weather worldwide, including Atlantic hurricane activity. ENSO cycles between warm, El Niño, and cold, La Niña phases. Each phase affects the Atlantic hurricane season differently. El Niño suppresses hurricane activity by increasing wind shear. La Niña enhances hurricane activity by reducing wind shear. For 2025, ENSO neutral conditions are expected. Section 8. Preparedness. Facing the potential threats. Regardless of seasonal predictions, preparedness is paramount. The forecast for an average to slightly above average season means there is a tangible risk. Every individual and family in hurricane-prone areas should have a plan. This plan should be reviewed and updated before June 1st. Waiting until a storm is approaching is often too late. Panic can set in, and supplies may become scarce. Thoughtful preparation now can make a significant difference in safety and recovery later. Key elements of a hurricane preparedness plan include several actions. First, assemble a disaster supply kit. This kit should contain essentials like water, non-perishable food, and medications. Include a flashlight, batteries, a first aid kit, and a multi-purpose tool. Second, develop a family communication plan. Designate an out-of-state contact person. Ensure everyone knows how to reach each other if separated. Third, know your evacuation zone and routes. If local officials issue an evacuation order, be ready to leave promptly. Staying informed is another critical aspect of preparedness. Monitor official news sources for the latest updates. The National Hurricane Center is the primary source for storm information. Section 9. Looking ahead. Navigating the 2025 season. As we stand on the cusp of the 2025 Atlantic hurricane season, several factors shape our expectations. The season officially runs from June 1st to November 30th. Early signs point towards activity levels that could be average or slightly above average. The first named storm will be Andrea. Key ingredients like warmer than normal sea surface temperatures are present. These could fuel developing storms. ENSO neutral conditions add complexity. Neutral years lack the strong guiding influence of El Niño or La Niña. We will closely monitor tropical waves from Africa. The National Hurricane Center will maintain its vigilant watch. They will provide essential forecasts and warnings. It only takes one storm making landfall to make it a devastating season.